Okay, so we're going to be dealing with operations of complex numbers. Complex numbers deal with imaginary numbers, and we get imaginary numbers by taking the square root of negatives. So here, the square root of -1 is equal to I, which means if I square both sides, that I squared equals -1. So these are two things that we need to have stuck in our brain for this entire lesson. The square root of -1 is I, so anytime you see the square root of -1, you can replace it with I, and I squared equals -1. So anytime you see I squared, we can replace that with -1. Extremely important. Okay. So here we're going to simplify radicals. So I have the square root of -36. So what I can do here is I can break this up and say that it's the square root of -1 times the square root of 36. Well, we know that the square root of -1 is I. We just talked about that. And then the square root of 36 is 6. So that's equal to 6I. And the I always comes after your after your number. Okay, so the square root of -81, I can say that that's the square root of -1 times the square root of 81. Well, the square root of -1 is I, and the square root of 81 is 9, so we get 9I. All right, and now I have 5 times the square root of -20. So this one's not going to be as pretty. But we can break this up and say that it's 5 times the square root of -1 times the square root of 20. So I have 5I times the square root of 20. But now I need to simplify the square root of 20. So the square root of 20 I can break up and say that it's 4 times 5. So this is 5I radical 4 times radical 5. We know the square root of 4 is 2. So this is really 5I times 2 times the square root of 5, which gives us 10I radical 5. So we're just simplifying radicals here. All right, when you're adding and subtracting imaginary numbers, you treat the I like you would any other variable. So treat it like x. You can only combine like terms. So 3 minus I plus 2 plus 3I, the 3 and the 2 can be combined together to make 5. And then the -I and the 3I can be combined together to be 2I. So we get 5 plus 2I. So if it's an I, they can be combined together, but anything without an I gets combined together. So this next one, I have 4 minus I minus 5 plus 8I. So what's important here is I need to distribute my negative. So I get 4 minus I minus 5 minus 8I. And now I can combine like terms. So 4 and -5 can be put together. So that's -1. And then -I and -8I becomes minus 9I. So I get -1 minus 9I. I'm just trying to, there we go. Okay. When you're multiplying complex numbers, again, you're going to treat it just like you would any other variable. So I times -3I becomes -3I squared. But thinking back to that very first page, we said that I squared equals -1. So anytime you see an I squared, we're going to replace that with -1. So we're really doing -3 times -1, which ends up being a positive 3. Okay, I have I times 4 plus 3I, so I'm going to distribute. So I times 4 is 4I. I times 3I is plus 3I squared. I have an I squared, so I'm going to replace it with -1. So I have 4I plus 3 times negative 1, which is 4i minus 3. And we always put the i's at the end, unless it's a radical. So we're going to rewrite this as negative 3 plus 4i. Okay, we're still multiplying here. So 5 minus 6i times 4 minus 3i. So 5 times 4 is 20. 5 times negative 3i is negative 15i. Negative 6i times 4 is negative 24i. And negative 6i times negative 3i is a positive 18i squared. Okay, so simplify a little bit. So 20 minus 39i plus, I now have 18, but instead of writing an I squared, I'm going to replace it with negative 1. Ooh. Okay, so now I have 20 minus 39i minus 18. So my last step is to combine like terms. So I get 2 minus 39i as my solution. Okay, so this is a mixture of everything. So we are going to start off with 3 minus negative 2 plus 3i plus negative 5 plus I. So I'm going to simplify this. I need to distribute my negative. So this is really 3 plus 2 minus 3i minus 5 plus I. And now we combine like terms. So 3 plus 2 is 5, minus 5 is 0, and negative 3i and positive I is negative 2i. So that ends up becoming negative 2i. I have 12 minus 7i minus 6 minus I, so I need to distribute. So this is 12 minus 7i minus 6 plus I. So 12 minus 6 is 6. Negative 7i plus I is minus 6i. So I get 6 minus 6i. And my last example of this is 4 minus 4i times 6 minus I. So this one I'm going to be foiling. So 4 times 6 is 24. 4 times I is negative 4i. Negative 4i times 6 is negative 24i. And negative 4i times negative I is positive 4i squared. So I get 24 minus 28i plus 4 times negative 1 because I'm replacing the I squared with negative 1. So 24 minus 28i minus 4. So I get 20 minus 28i. So that's addition, subtraction, and multiplication. Now we're going to talk about division. When we divide complex numbers, we take the complex conjugate of the denominator and multiply the numerator and the denominator by that complex conjugate. And what the complex conjugate means is the sign in front of the imaginary number is changed. So a plus bi, the complex conjugate is a minus bi. If you start off with a minus bi, the complex conjugate is 8 plus bi. So using real numbers, let's say I have 3 plus 7i. Then the complex conjugate is just going to be 3 minus 7i. If I start off with negative 2 minus 5i, then my complex conjugate is going to be negative 2 plus 5i. So the only thing that gets the sign change is the I. But nothing else does. So if I start off with 4 minus 6i, it's going to be 4 plus 6i for the complex conjugate. So the complex conjugate is pretty easy to find. So you're going to multiply top and bottom by that. So 5 plus I divided by 2 minus 4i. You're going to go to your denominator and take the complex conjugate. So here the complex conjugate would be 2 plus 4i. And you're going to multiply top and bottom by 2 plus 4i. So 5 plus I is going to be multiplied by 2 plus 4i. And 2 minus 4i is going to be multiplied by 2 plus 4i. So you're going to be doing FOIL twice, basically. Okay, so here I have 5 times 2 is 10. 5 times 4i is 20i. I times 2 is 2i. And I times 4i is 4i squared. So I get 10 plus 22i minus 4. I went ahead and skipped a step, so I squared is negative 1, and negative 1 times 4 is negative 4. So my numerator ends up being 6 plus 22i. Now I'm going to repeat that process using the denominator. So 2 minus 2i. Oh, my pen isn't working. Okay, 2 minus 2. Oh my gosh, I'm saying something wrong. 2 times 2, I'm going to do it up here, is 4. Then I have 2 times 4i is 8i. Then I've got negative 4i times 2, so negative 8i. And then negative 4 times 4i is negative 16i squared. So I get 4, 8i minus 8i is gone, so plus 16, since I'm replacing the I squared with negative 1. And negative 1 times negative 16 is positive 16. So that ends up becoming 20. So my numerator is 6 plus 22i over my denominator is 20. And then my last step is to simplify. So your numbers, 6, 22, and 20, all have to be simplified by the same number. So if 2 goes into 6, 22, and 20, so I'm going to simplify everything by 2, so 6 becomes 3, 22 becomes 11, 20 becomes 10. So I end up with 3 plus 11i over 10. Okay, so it's just FOILing twice. You have to get the complex conjugate of the denominator and then multiply top and bottom by that complex conjugate. Okay, so 3 plus 7i divided by 8i. Okay, you go to the denominator, which is 8i, and you take the complex conjugate, which here is just going to be negative 8i. Okay, so I'm going to FOIL it out. So 3 times negative 8i is negative 24i. And I know this looks really sloppy. I didn't give myself a ton of space. And then 7i times negative 8i is negative 56i squared. So that is negative 24i plus 56. And then I'm going to rearrange it. So my numerator is 56 minus 24i. My denominator, I've got 8i times negative 8i, so that's negative 64i squared, which is positive 64. So I have 56 minus 24i all over 64. And I want to look and see, is there a number that goes into all three numbers, 56, negative 24i, and 64? And 8 goes into all of those. So I can simplify all three of these by 8. So 56 will become 7, 24 becomes 3, 64 becomes 8. So we end up with 7 minus 3i all over 8. That's my solution. So you take the complex conjugate of the denominator and then multiply the numerator by that complex conjugate, multiply the denominator by that complex conjugate, put it together, and then simplify if you can. Now, the last thing to talk about is when I is being raised to a power, we can instantly find out what that is going to end up being. So first off, I to the first power is equal to the square root of negative 1. Okay. I to the second power is equal to negative 1, which we